In this video, I'll walk you through the post-lab assignment for Lab 10, Analysis of Baking Soda. So on this post-lab assignment, the first thing that you have is a chemical equation that you need to complete and balance. You can do this just based on the type of stuff we've been covering in class this week, or you could look it up on the internet. There are actually two different ways that you could see this equation balanced. There's two different versions of the product of this reaction. Whichever one you choose, it's not going to have an effect on the rest of your post-lab assignment, so don't worry too much if you see two different options for what you would write over here. Complete it and balance it. The most important part are the stoichiometric coefficients on the left-hand side. And then in problem number 2, you're going to be reporting the data that you collected in the experiment. You have a mass of sodium bicarbonate that is impure that you used for this experiment, and then the final burette volume that you've recorded right here. You'll also be reporting the molarity of the HCl solution that you used in the experiment. So this is something that you're just going to copy from a bottle. And I'm just going to fill some random data in just so that we have kind of something to work with. So let's say that I used 2.1 grams, and actually I'm just going to try to keep this real simple. Let's say I used 2 grams, and let's say my final burette volume was 40 milliliters, and let's say that my molarity of the HCl solution was 1.0 molar. This is not correct data. I'm going to be really unhappy if I see this data on anybody's lab assignments because this is not real data. So what we're going to do next is work a little bit on the HCl solution. First, you're going to report the total burette volume for your 2 samples that you worked with. The total burette volume is the difference between the initial and the final burette volumes, and since the initial is always at 0, it makes it super easy for us to report the total burette volume. This is one of the reasons why burette volumes are marked backwards. The other thing I want to put as kind of a side note here, occasionally there are some students that really struggle to figure out what they should be writing in this box, like they really want to make it more complicated than it needs to be. There are some pretty specific instructions in part 6 that tell you how to read the burette, and you read the burette exactly the way that the numbers are displayed, even though we all know that it's backwards, because it all works itself out right here in the end when we do the subtraction. So we've got our total burette volume, 40 milliliters. And again, if you're struggling with how to record this number, please either ask me or just reread this part 6. And then also in question number 4, we're going to calculate the moles of HCl that we used for each one of these samples, and that is going to be calculated using the molarity of the HCl. The molarity in my hypothetical here, and again, this is not correct, the molarity of the HCl, 1 molar, that means that we have 1 mole of HCl in every liter, and all I have to do is multiply by the volume that I used in units of liters, which is going to be 0.04 liters. And I don't know why I wrote 40 both times here. Your data is not necessarily going to be the same for both of your samples, but it should be pretty close for both of your samples. So then what we're going to do is calculate the molecular weight of sodium bicarbonate, NaHCO3. You can either add up all of these individual atomic masses, or you can just look it up on the internet. And then we are going to calculate the moles of pure NaHCO3. Now, this is something that quite a few students get messed up on. You cannot convert the mass of impure sodium bicarbonate from problem 2 into moles of pure sodium bicarbonate. So what that is saying is that you cannot use this number right here and do a gram to mole conversion on that number, because this is an impure sample. So this 2 grams is not 2 grams of NaHCO3. There's something mixed in there as well. We don't know how much of this 2 grams is the NaHCO3. That's what we're trying to figure out. So don't do a gram to mole conversion. It's not going to work. What you need to do is a mole to mole conversion. What am I doing here with my units? mole to mole conversion. So in problem number 4, we determined that we used 0.04 moles of HCl. And up here at the top of the page, you have a balanced equation that's going to give you the stoichiometric relationship between HCl and NaHCO3. That's what you're going to use to solve this problem right here. So you're going to take your moles of HCl. I determined 0.04 moles of HCl, and you are going to multiply that by a conversion factor that lets you convert moles of HCl into moles of sodium bicarbonate. And the numbers that you're going to use in this conversion factor are the stoichiometric coefficients from this equation once it's been balanced. I'll just put some random numbers in here. Let's say it's 2 and 3. That's probably not right, but you'll balance it yourself and you'll get those numbers in there, and it'll be whatever they are, you'll copy them into this problem, and that's going to give you, if you can see how these units cancel out, that's going to give you moles of pure NaHCO3. 0.04 times 2 divided by 3 is 0.0267. The next column over on this is asking us to calculate the mass of pure NaHCO3. Now this is going to come from the pure moles of NaHCO3. So we're going to take this mass, 0.0267, and we are going to multiply it by the molecular weight, divide it by the molecular weight to figure out the number of moles. I am all sort of messed up tonight. Moles, we are going to multiply it by the mass of NaHCO3, and you have calculated the molecular weight of NaH3OC up here in problem number 5. So that's going to go into this spot. This is just going to be a 1. And your answer here is going to be the mass of the pure NaHCO3. Then what we're going to do is come down to this last spot and determine the impurity of our original sample. We've got the mass of pure NaHCO3. You're just going to copy that from this box right here, just copying it. You've got the mass of the impure sample. That's also a number you're going to copy. You're going to copy that from problem number 2. That impure sample mass is going to go right here. And then you're going to calculate your percent purity using this equation right here. Take the pure, divide it by the impure, multiply it by 100. That will give you your percent. Maybe my pure mass would be 0.5. I don't think that that's what it actually would be. My impure was 2 grams. And so my percent purity would be the pure divided by the impure, multiplied by 100, which is 25%.